Assalamualaikum and hello everyone. So today I'm going to discuss a question from College Matriculation Labuan year 22 and 23, which is a topic from chapter 1. So let's have a look at the question. So question 1A. Compound X contains carbon, hydrogen and nitrogen. Combustion of 2.5 gram of X produces 3.44 gram of water and 5.58 gram of carbon dioxide CO2. Determine the empirical formula of X. Okay, so firstly, as in the question said that compound X is contain carbon, hydrogen and nitrogen. So I will usually for me I will write it this way first. So as we know, combustion will add O2, then the result of the combustion is CO2 and hydrogen. So firstly, as usual, to find empirical formula, we need to have the mass of the element first. So firstly, we're going to find the mass of carbon, which is we will use the molar mass of the carbon over the molar mass of CO2 times the mass of CO2. So we can get the mass of carbon, which is we will get 1 mark. Then we find the mass of the hydrogen, which is the work step is same as mass of carbon. We use the molar mass of hydrogen, then over the molar mass of H2O, then times the mass of H2O, then we will get the mass of hydrogen, which is 0.3822 gram. So we will get 1 more mark over here. Then lastly, we need to find the mass of nitrogen. Since we already got mass of carbon and hydrogen, so we just take the total mass, which is 2.5 grams, and subtract it with mass of C and mass of hydrogen. So we will get the mass of nitrogen is 0.5960 gram. So we will get 1 more mark over here. Then we can continue to find the empirical formula. So as usual, if you want to find the empirical formula, we need to use this table. So we just fill in the table, the mass, then we find the mole here, mole of carbon, hydrogen and nitrogen. Then we among all of the element, we need to find the most small number of mole. Then we will divide the number of mole with all of the element. So as we can see here, the smallest number of mole is nitrogen. So we divide all number of mole of element with nitrogen number of mole. So we can get here is 3. For hydrogen is 9, and for nitrogen 1. So the empirical formula for element X, for compound X is C3H9 and N. So we will get 1 more mark over here. So the total is 6 mark. So when we find the mole is 1 mark, and simplest mole ratio is 1 mark. So the total is 6. Okay, so for question B, the density of an aqueous solution containing 50% of ammonia NH3 by mass is 0.986 gram ml -1. Calculate 1 mole fraction of ammonia. Okay, so as we look in the question, it didn't state the mass of the solution. So we need to assume the mass of the solution is 100 kg. So we will get 1 mark over here. Then we need to state the formula for mole fraction, which is XA equal to NA over N total. So we will get one more mark over here. Okay, so firstly we need to find the number of mole of NH3, which is we already get the mass of the NH3, which is 15 gram. So we divide by its molar mass, so we can get 0.8824 mole. So we will get one mark over here. Then we will calculate the number of mole for H2O. So we doing the same step, which is the mass of H2O. Then we divide it with its molar mass. So we will get the number of mole of H2O is 4.722 mole. So we will get one more mark over here. Then we just substitute the value to find the mole fraction of NH3. So as we can see here, 0.8824 over the total number of mole of the solution. So we can get we get 0.1574 as the answer. Remember, mole fraction does not have a unit, so we just leave it like that. So we can get one more over here. Then let's continue to question B2, which is we need to find the molarity of the NH3. So, as we know, the formula for molarity is mole of solutes divided by mass of solvent. And this, I'll take note that the mass of solvent need to be in kg. So, as we already find the value, which is mole of solute is 0.0824, and the mass of solute is 85 gram. Then we convert it into kilogram. So we will get 0.085 gram. 0.085 kilogram. Then we just can continue calculate it. Then we will get 10.338 mole kg. So we will get one mark over here, and we will get one mark at the formula. Okay, so let's move on to the next question, which is we need to find the molarity of NH3. So, as we know, the formula for molarity is mole of solute over volume of solution. We need to state the formula so we can get one more here. So, we already have the number of mole of solute, but we didn't have the volume of solution. But the question has gave us the density value, which is 0.986. So, as we know, the formula for density is mass of solution over volume of solution. So, we also already assume that the mass of solution is 100 grams. So, we can directly substitute the value and we can get the volume of solution, which is 101 and 42 ml. So, we can get one mark over here. So, we already have all the data needed for we to calculate the molarity. So, we just substitute the value, which is 0.8824 over 101.42 times 10 negative 3. Why we need to put times 10 negative 3? Because in finding molarity value, the volume of solution need to be in liter. So we need to convert it, and we need to put this in order to convert it. You also can convert the value before substitute inside the formula. So after we substitute the value, we can get the value for the value of molarity, which is 8.70 mole at liter negative 1. So we can get one more mark over here. So the last question, C. A student would like to prepare 250 ml of 0.25 mole L negative 1 lead to nitrate PbNO3 solution. 1. calculate the mass of PbNO32 required to prepare the solution. 2. Based on the information in B1, give two main steps that should be carried out to prepare the solution. Okay, so back to the question. Firstly, we need to find the mass of the PbNO32. As the compound is in liquid state, so we can use this formula, which is N equal to mv over 1000. So we just substitute the value, which is the molarity of the solution is 0.25. Then the volume of the solution is 250 ml. Then over 1000, so we can get the mole of the lead to nitrate is 0.0625 mole. Then we can find the mass of lead to nitrate by using the mole, then times it with the molar mass of PbNO32. So we use 0.0625 times the molar mass of the compound. Then we can get the mass of PbNO32 is 20.7 gram. Then the second question, which is question 2, that they want the two main steps, so we can use this step. First, we can dissolve 20.7 gram over here of PbNO32 in a small amount of distilled water in a beaker. Then transfer the solution into a 250 ml volumetric flask. So here is the first step, so 1 mark over here. Then the second step is add distilled water into the volumetric flask until the solution reaches the calibrated mark. So 1 more mark over here, so we can get the total. For the C1 question, we can get 1 mark over here, then 1 mark over here. So we can get all the marks. So that's all from me. Thank you.